Hi guys, this is Unit 7, Lesson 6, Creating a Model from a Dataset. Example 1, you collect data from several people who each owe money on a student loan. Each of these people have yet to make a payment. This means that each month when a payment on that loan is due, these people are being charged interest. That means the total amount that they owe is increasing each month by their interest or by a multiplier. In this situation, the independent variable is the number of months that have passed in which each person's loan has not been paid off. The dependent variable is the total balance owed on the loan. Without using a scatter plot, what is the best model of this data set and how do you know? Without using a scatter plot, you know that the dependent variable, or the amount of money owed, will be higher for the people who have owed money for a longer time. This is because for each month that goes by, the balance of that person's loan is multiplied by the interest rate, a percentage. With that information, you can determine that the best model for this situation will be exponential. There will be a sharp increase in money owed with the data points that represent a higher number of months having gone by. So basically, if you're like me and you don't have a math brain and you don't understand what they're saying, because we're dealing with a percentage, we know we're dealing with multiplication. Every month it's being multiplied by a percentage, and that's going to be an exponential growth rate, because the more months that you haven't paid off your loan, the higher the payment's going to get every time, because the percentage that you're paying every month is going up every month because your loan is bigger every month. Does that make sense? Because you borrow $1,000 and the next month you owe $1,005, and the next month you have to pay interest on $1,005. So let's say that goes up to $1,010, and then you have to pay interest on $1,010, and then the next month you have to pay $1,020, and then $1,000. You get what I'm saying? It exponentially grows. Okay, that's how they know. Oh my goodness, it went away. This is example 2. For a science experiment, you and your friends decide to make a soda bottle launcher using mint chews, which are Mentos, but the book can't say Mentos because that's a copyrighted brand name, and some soda bottles. You're going to make a scientific reaction and record it. From that recording, you will collect data on the height of the soda stream starting at the beginning of the reaction. Here is a scatter plot that represents the data you collected from a few different bottles. Now you are interested in choosing a model that represents the data that you have collected so far. You hope to use this model to predict the maximum height of your final bottle experiment. What type of model should you choose to represent this data set, and why? Well, you can look at this graph and see that it created a parabola. So the trajectory of the height of your soda explosion over time is one of a parabola, as the scatter plot represents. Your soda explosion grows quickly, then slows down. Because of the parabolic shape of this science experiment, a quadratic model is the best choice. Quadratic models and parabolas always go together. Okay. Check-in. Describe at least 2 strategies that you can use in determining the best model for a set of bivariate data. First, if given the scatter plot, you can use what you know about the shapes of linear, exponential, and quadratic functions to determine the best match for the given data set. So if you have the graph, just look at it and you can tell what type it is. You can use the context of that data to help you determine the best model. So if you just have the words, you can read it and dig it out, the information, and be like, oh, okay, this is what it is. This means considering what type of change is happening in that context. For example, with a common ratio or constant rate of change, and then connecting that type of change to a type of model. So like our first example where you were dealing with interest, where you know interest is going to cause exponential growth. Okay, we know that. We just know it. You have to know that. Choosing the best model for a data set. We have linear models, exponential models, and quadratic functions. A linear model is when a data set appears to increase or decrease in a straight line and there is a constant rate of change. An exponential model is when data context involves a multiplier over time, like interest, and it could represent growth or decay. Either way, it's an exponential model. The graph is a curve that starts slowly, then accelerates quickly, or vice versa. It starts slow and then goes quickly and then decreases. Okay. Quadratic function is when a situation can be modeled with a parabola, and it's when the y values decrease and increase at the same rate, or they increase and then decrease. Okay. Here's a check-in. Match each description of a data set to the best model. So the trajectory of a basketball compared to the number of seconds since it was shot. Okay, if you throw a basketball, it's going to be a parabola. It's going to go up and then come back down. So this one has to be quadratic. A data set collecting people's number of social media followers and social media likes. Okay, so this one is probably going to be exponential because the more followers you have, the more views you get, the more followers you get. It just grows exponentially. It just does. Okay, and the number of cell phones in America from 1980 through present day will probably be linear because it's just going to continue to increase all of the time. Okay. It might be exponential as well, so these could be interchangeable. I'm not entirely sure. Again, it's not super clear. It's this book. I've given up. Match the names of the graphs to identify types of graphs for bivariate data sets. This one right here starts out kind of slow and then goes quickly, so it's exponential. This one is a parabola, so it's quadratic, and this one is a straight line, so it's linear. Another check-in. Choose one of the following answers for each scenario to identify the best method to represent the data. Answers may be used more than once or not at all. So data that's collected to show that students' test scores tend to increase by about 1 point for every half hour spent studying. That's a steady rate of change. Half hour, 1 point, half hour, 1 point, half hour, 1 point. So this one is going to be linear. Let me grab my tools. This one would be linear, okay, because it has a steady rate of change. It's going to be a straight line. A study shows the bear population in Kentucky is about 95% of the previous year's population. 95% means we're dealing with a percentage or a decimal, okay, which means that we're going to have a decline. It's going down every year because it's not over 100%, okay? So that is going to be exponential, okay? I'm just going to go that far. The data collected from rocks being launched vertically upward indicate a typical initial velocity of 128 feet per second. So we're only dealing with the rocks being launched vertically upward. We're only looking at that. We're not looking at them falling. And we're looking at the velocity of 128 feet per second. This is probably linear. Everything's very steady, very stable, okay? A company tested a sample of its basketballs and found them to bounce about 70 inches high when thrown from the top of a set of bleachers. So it's thrown, comes down, it bounces, and it comes back up about 70 inches, okay? This one is probably quadratic because it's going to be a parabola, okay? Quadratic. A study shows that on average, plumbers charge an initial fee of $50 to make a house call and $25 an hour for labor. So you're going to start on the y-axis at 50 and then $25 for every hour. Straight line, linear. Data about the River Falls population shows an average of 22% growth each year. We're dealing with a percentage, so we're dealing with multiplication. So it is going to be exponential. It's going to start slow and then grow quicker and quicker. Question number 1, this is all you. The scatter plot represents some data collected from a tennis team. They are examining the heights reached by different tennis balls after multiple bounces. Each point represents a piece of data collected from their experiments. For example, 3.5 represents a ball's height of 0.5 after 3 bounces. What model is the best fit for this data and how do you know? Pause it, figure it out, come back. You can look at this and see that this is an exponential data set. Okay, it has an exponential, starts out steep and then it levels off. The data is decaying in an exponential manner, forming a curve that eventually flattens out as the x values get larger and larger. Here's question 2. The day after your history test, your teacher collects data from all of his students about their test grade and the number of hours each student studied for the test. He brings the scatter plot of that data to your class. Using the context of the data, consider what model would be the best fit for this data and how do you know? Pause it, figure it out, come back. A linear model would be the best fit for this data set because in general, the longer you study for the test, the better you will do on it and the higher your grade will be. Of course, there will be exceptions to this rule, but you can imagine that most of the points in the scatter plot will follow that rule, creating a scatter plot best described by the function straight line of a linear function. So it will probably have stuff like this going on out here, but it's still going to be a linear function. This is at the end of the lesson. When Pinocchio tells a lie, his nose grows to approximately 30% of its original size. You've collected data comparing the number of lies he has told and the size of his nose after each lie. Based on the context of this data, which model is the best fit for this data? Pause it, figure it out, come back. Dealing with 30%, which means we're dealing with a percentage or a decimal place. We're dealing with multiplication. It's going to be exponential because at first his nose is going to grow kind of slow and then it's going to grow faster and faster and faster. Okay. Practice question 2. The scatter plot represents data collected about how often students between the ages of 2 and 18 play with toys. Each point represents a piece of data collected from each student. For example, 8-7 represents an 8-year-old who plays with toys for 7 hours a day. Which model is the best fit for this data? Speed round. Boo, 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 boo. It's a parabola, which means it's quadratic. Practice question 3. 2 balls are hurled at a constant rate and a consistent angle from the top of a 35-foot tall building. The preceding scatter plot represents the number of seconds it took for each ball to reach the ground from a certain height. Each point represents a piece of data collected from each throw. For example, 4-9 represents that after 4 seconds, a ball will be 9 feet in the air. Which model is the best fit for this data? Speed round. Boo, 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 boo. You can see from this that we have a curve, so it's definitely not linear. Okay. And we would have to have data over here for it to be quadratic. So you can see it is getting steeper as we get over here. It's hard to tell. It's going to be exponential. Quick check question 1. The data in the graph represents the relationship between the amount of time spent studying the test grades, and each point represents a piece of data collected from students who took a test and the grade that student received. For example, 270 represents a student who studied for 2 hours and received a 70. Decide which model best fits the data. This one you can just look at and tell which type of model it is. This one is not an option. Quick check question 2. The data in the preceding graph represents the value of baseball cards over time. Each point represents the value of a basketball card after a certain number of years. For example, 950 represents a 9-year-old basketball card that is worth $50. Which model best fits this data? Again, you can just look at it and determine which type of model it is. No model is not an option. Here's our second half of the lesson. Let's talk about regressions. A regression is an approximate equation based on the type of function that is a best fit for the data. So they look a little bit different from the parent functions. The only thing that is different is that instead of an equals sign, they have this little loop-de-doo. I don't know what this thing is called, so I'm going to make up a word for it. The woohoo symbol tells you that these are approximate equations describing a data set rather than an exact function. So when you see this, it means it's a regression. Okay. Here's a check-in. What is a regression? A regression is a model of a data set in the form of an approximate equation. Using the formula of the parent function that best fits the data, the regression describes a function that is closest to that data set. I'm going to come back here for a minute because I need this in my notes. My notes are severely lacking. If you don't have this in your notes, you should put it in there. For this quadratic function down here, this is the HK version of the formula. You can also have the standard f of x, woohoo, and then ax squared plus bx plus c. Okay, that's the other version, but it didn't tell you this back here, and then it asks you about it later because this book is poop. Why might you need a regression? A regression model can help you describe a data set. Additionally, having a regression with an explicit formula allows you to predict future points easily by plugging in certain values. So basically, we're going to use these regressions to find like the 15th one or the, whatever. Woohoo. With mint chews and some soda bottles, you made a scientific reaction and recorded it. From that recording, you collected data on the height of the soda stream starting at the beginning of the reaction. The scatter plot represents the data you collected from a few different bottles. You decided that the best model for this data set would be quadratic. Write the regression that best describes this data set. So in our notes, you know that the quadratic formula is f of x, woohoo, a times x minus h squared plus k. Okay, so that's written all right here. So it's best to use the vertex form, which we have right here, because we can find the vertex from the scatter plot really easily. It's right there. Okay, so from this data, you can see that the vertex is around 3 and 36. Okay. If we're using technology to find the regression, we can find this point exactly, but we're doing this by hand, so we're just going with 3 and 36. Identifying the value of a is the biggest challenge in writing this regression. Because the data's parabola is facing down, we know that a is going to be negative. Okay, we know that much just to start with. From your knowledge of the quadratic parent function, which is right here, you can notice that this parabola is a bit thinner than the standard function. Normally they're a little more wide, okay? This looks skinny, meaning a will have an absolute value larger than 1. Okay, they expect you to just magically know that. I would not magically know that. Finding the best value of a is most easily done with technology, but for this example that is being done by hand, a value for a anywhere between -3 and -5 is a good choice. Don't worry, you don't need to do this at the end. I don't know how they expect us to know that. You can confirm this choice for a by using the h and k values found earlier, which is this vertex thingy, okay, and any other point from your scatter plot. They chose 5 and 18. So first, plug these values into the vertex formula, which is right here. So y is equal to 8. Ooh, let's get a different color. Y is equal to 18 equals a. They didn't tell us. We're verifying a. A is equal to x is 5, h is 3 squared plus k is 36. H and k are the vertex, and then 5 and 18 are the random point that they picked. So we're going to solve this for a now. So PEMDAS says that we need to do parentheses first. So we have 18 equals a times 2 squared plus 36. Now we need to do exponents. So we have 18 equals 4a plus 36. Now we just need to solve for a, so subtract 36 from each side. And that's going to give us -18 equals 4a. Divide both sides by 4. And that's going to give us a is equal to negative something. Let's get a calculator. 18 divided by 4, -4.5. Okay, -4.5 is going to be our answer for a, which is between -3 and -5, so we're good. That was the point of all of that. Combining the elements of vertex form, you can create this regression model for the given data set. Taking this formula, f of x is, woohoo, a was -4.5, x minus h, which is our vertex, is 3 squared plus k, which is 36. Okay, so that's how we found that formula. This is another example that they didn't number, so I numbered it 1.2. Previously, you chose a linear model for Stephanie's lawn mowing business. The following graph shows the data that she's collected so far for the tip amounts compared to yard sizes. Based on the scatter plot, write the regression model to represent Stephanie's data. So again, first thing we have to do is figure out what kind of model this is. Looks linear to me. Okay. So I don't know why I have two of the same slide. Previously, you chose a linear model for Stephanie's lawn mowing business. So we look for our linear formula, which is f of x, woohoo, mx plus b. Okay. The following graph shows the data that she's collected so far from the tip amounts compared to yard sizes based on the scatter plot. Write the regression model to describe Stephanie's data. So to create a linear regression model, you need to use the formula. To find m, use the scatter plot to identify the rate of change or slope of Stephanie's tips by examining the first point, which they're saying is at 2, 9, and the next point, which is at, they say 4, 15. I don't know how that's the next point, but whatever, which both fall right in line with the something, that's obviously a typo, of the data. You can determine the slope. I guess because they're looking at, I don't know why they picked those two. But to find the slope, you go y2 minus y1 over x2 minus x1, which is going to give us 6 over 2, which gives us 3. So our slope is 3. Ding! To find b, the y-intercept, it's going to be a little trickier because it doesn't show us what b is on the y-axis. So to find this value, you need to extend the trajectory of the points backwards to determine where the approximate line would intersect with the y-axis. So using the slope that you found earlier will help ensure that your choice is a good estimation. So basically we'd go down 3, so we're at like 6 now, and over 1, okay? And then we'd go down 3, 1, 2, 3, so now we're at 4 and over 1, so it'd be like there. So the y-intercept would be 4. Hey, I did it right. Using that information, you can create the linear regression model f of x, woohoo! 3, which is our slope, x, plus 4, which is our y-intercept. Here's example 2. The scatter plot represents the heights reached by different tennis balls after multiple bounces. Each point represents a piece of data collected from their experiments. For example, 3.5 represents a ball's height of 0.5 after 3 bounces. You decided that exponential is the best model for this situation as the scatter plot follows the form of exponential decay. Create the appropriate regression model for this given scatter plot. So first you find the formula. Knowing that an exponential model will be best for this data, you can start by considering the formula that you'll want for the appropriate regression, which is f of x, woohoo, a times b raised to the power of x. To find a, you need to approximate the y-intercept for this data set. Based on the one point on the y-axis, which is right here, the best choice here is a equals 4. Next, find b, or the common ratio. Because this scatter plot displays decay, b must be between 0 and 1. It has to be a decimal point. If you follow the clumps of points as the x values increase by 1, the values seem to be cut in half for each single increase in x, or each increase in the number of bounces. Because of this regular pattern, you can use b equals 1/2. So we're going from like 4 to about 2. Oh no, this is 1. Okay, 4 to 2 to 1 to 1/2 to 0. Okay, looks like they're getting cut in half. With those two values, you can now complete your regression formula f of x, woohoo! 4, which is our y-intercept, and 1/2, which is our rate of change, okay? Raised to the power of x. Note that if you are using technology to find the regression model, the answer might vary slightly from this, as technology is able to provide a more exact answer. Here's question 1. This is all you. The scatter plot represents data collected from students about their latest math test, showing how many hours they studied and their score on the test. Molly is working on writing a regression model to describe the data set. So far, she's written f of x, woohoo, 4.2x plus b. What would be the value for her to include as the y-intercept on this model, and how do you know? Pause it, figure it out, come back. On the y-axis, the data is clustered around 75. There's 2 points, but they're both close to 75, with a point at 75 and one right above it. Because of that, the best value for b is 75.5, making the regression model f of x, woohoo, 4.2x plus 75.5. If you said like 75, it's fine. Your answers at the end are more multiple choice. Don't stress. Here's question 2. The scatter plot represents data collected from a group of friends playing a zombie video game. They kept track of how many zombies appeared in each round of the game after different amounts of time. They're hoping to create a regression model to better predict how many zombies will be present at certain times throughout the game moving forward. Help these friends write a regression to describe this data. Pause it, figure it out, come back. Looking at this, you can see it's exponential. So our formula is going to be f of x, woohoo, a times b raised to the power of x. Gosh, sorry, my computer's lagging. Okay, and a is going to be the y-intercept, and it's hard for me to tell on this graph because it's between 0 and 20. So I'm guessing somewhere around 5. And then it's going, let's see, like 0 to something to, I don't know, 15. So maybe 5, 15, a little over 20, 50. Maybe it's doubling. Maybe this is like 25, 50, 100. Yeah, it looks like it's doubling to me. So what they are saying is that this is about 3 and that it's doubling. Okay, so that's how they found that. End of the lesson. Which form is used when a regression model is best described by a linear function? Speed round. Boo, 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 boo. Whoops, sorry. This is it for the linear function. What type of function best describes the data of the regression model? Pause it, figure it out, come back. If you look at it, you can see it's exponential. And this is the correct formula for exponential. Okay, here's quick check 3. Jorge needs to create an appropriate regression model given the bivariate data set. Which of the following should he create? Well, you can look at it and see which type it is. You need to look and see what your formula should look like for that. Come over here, see if you can find the correct formula. Well, they're all in the same format, so you don't have to worry. This is quadratic. Okay, so this one, A, should be your rate of change. They're all either, you need to figure out, is it positive or negative? And you can tell that based on the direction the parabola is facing. We talked about this earlier. So you should be able to tell right away whether it's positive or negative, okay? X stays the same, and then H and K are your vertex points, which is right here. And H would be your X value, and K would be your Y value of this point right here. So you should be able to figure that out. Here's quick check question 4. Which of the following is an appropriate regression model given the bivariate data set? You can look at that and tell it's linear, and they're all written in linear format. So this first number is the slope. So you need to figure out what the slope is here. Obviously, it's going to be 9. So figure out if it's positive or negative. And then this number is the y-intercept. So you need to figure out what the y-intercept is, and then you know this answer. Quick check question 5 says, which of the following is an appropriate regression model rounded to the nearest 10th given the bivariate data set? Well, you can look right here and tell which formula it is. It's going to be linear. They're all written in linear, okay? So the slope, to find the slope, you're going to do y2 minus y1 over x2 minus x1, and you can use any 2 consecutive points on here. Okay, these are the x values, these are the y values. Okay, so that will find your slope, which is obviously going to be 111.9. So you need to decide if it's positive or negative. And then this number over here is going to be your y-intercept, which isn't shown here. So you'll have to do some extrapolating. You're going to have to figure out where that is supposed to be. Question time. My question for you is, how many of these did I screw up? Because I'm so tired, I just don't care.